Okay, so we're not going to do the example. We do 17137, but I think it's related to this example. So do the figure, but don't put any value, I guess, for the angular acceleration. Okay. All right. So you do your figure. I do my figure. 17137. We might come to this example to check some of the data, like the position vectors and so on. So, all right, so let me do that. First, I'm doing that over here. Okay, with the groove over here. All right, then that one has a slide on it. Okay. Okay. So point B, point C, point A. Yeah, the dimensions would be unchanged. Yeah, take the dimensions. Okay, 350. Okay, then. Basically, you see that point D is like if that was a circle, no? Would be the center of the circle, okay? And that's 500. So let me call it R. Call it R equal 500. And then the point over here, this is, so this is normal that this is R or 500. And this will also be 500. Okay, but that one doesn't have to be R. And everything would be obviously 1000. Okay. Yeah. Yeah, it has to be 500. The distance between D and C needs to be 500. The only one that doesn't have to be 500 is the A and D, but it happens to be 500 here. So let's see. Yeah. So let's see what they give us in problem 17137. See if there's anything different than that. So put down 137. Okay. So suppose that the curved bar in example 1979 has a clockwise angular velocity. So the curved bar, let's call that one then, I guess, omega BC. Is that fine? And if they say clockwise,
isn't the curve by AB?
No, the one that is curved is BC, no? AB is straight. So let's see. Suppose that the curve bar in example 79 has a clockwise angular velocity of 4. So if it's clockwise, what does that mean? Negative 4 radians per second. And a clockwise angular acceleration, so alpha BC, positive 10 radians second square. What is the angular acceleration? Of the bar AB. So basically, this is what I've got over here, okay? Okay, so before finding the accelerations, what do we need to find? The velocity. So again, the idea is always to find the velocity of one point from two different locations. In this case, we can find the velocity of which point from which two locations? B from C and A, no? So then, when do we have the relative term? Is when the distance between those 2 points is not fixed, changes, no? So let's first do the easy one, will be velocity of B from point A there is no relative terms, will be VA plus omega AB cross S of B with respect to A. What is VA? 0. So you get IJK of 0, 0. Omega B is the unknown. What is the position of B with respect to A? Or is it known, or do we need to calculate that?
It's known. It's 1,000.
AB is known or AC is known?
The position.
We know the positions of all of them.
Well, with the Y,
We don't have the X, no?
yeah, we have the Y.
But we have the
We
Y.
have the X. We know it.
So I guess let's look at the figure more in detail, okay? We need to look at the figure more detail. That's why push down, up or down here, moving up. Yeah, this is, you see, this is here. Position of B with respect to A, so you see it's 350, but this is going to be end up being 857. So let's see what that happens. So basically, you see, you need to go down over here, no? All right, so the F16 were gone. All right, so okay, so we need to do this, no? This little trigonometry. All right, so let's do it. So let's see this. What is the fastest way to do this? So basically, yeah, that looks like it's almost on top of C. So, all right, let's redo a more small figure, I guess. For D over here, C over here. Then can we just say that B is over here? So we know that distance here, D to C, is 500. The vertical distance here is 350. I think they call it beta, no? The solution over there, no? I think what's called beta. Okay, so how can you find beta? You know the height, you know this. Tangent beta will be equal to what? 350 over 500, no? So if you take your calculators, what do you get for beta then? I think on the solution I like 44 something, but go and check.
I got 35. Inverse and
35? Let's double check and see what's. I mean, maybe I didn't pay attention. Okay, it's just maybe it's 35. What do you have?
Because the distance from D to B isn't exactly.
No, they take the sign. So let's see what they take the sign. Because this is also 500.
Wait, because it's the circle.
Right.
Radius.
This is a circle.
So the hypotenuse.
But this is not 500. Yeah, so, okay, I see. So, you see, my mistake. Good that we're able to check then. So we take the sign, because that distance is not 500. That's what we're trying to find, no? So you see, so take the sine beta. Correct, so if you take the sine beta now, is it 44?
Yeah, 344.
You take the sine beta. 44.4 degrees, okay? Okay, so now if you want the X position of B with respect to A should be equal to what? If I go from here, would be the 500 plus what? we need to find what would be, so 500 is from here to here. We need to find how much will be now that distance here, no? So it should be plus, okay, I'm using cosine of beta, no? And this is gonna give you what? I think it's 157.05. Okay, you want to be accurate, 0.05 millimeters. Okay. A little bit of math. We have to do some little trigonometry, no? So what does that mean over here is that distance here, B with respect to A, we go back to this one here is 857.05. And what is the Y? 350 and 0. If you want here, sometimes I do this in order to make sure that you don't mix the values, but okay, so you want here, you can write so that since we jump, BP will be equal to what? Will be equal to negative 350 omega AB, and will be equal to 857.05 omega AB. And that would be our first relation. So one thing, guys, you see that this is why it's important. I always say to do nice figures. You see, I did here the mistake between sine and cosine because what? I thought that distance here was going to be 500, no? And I think everything came because I did not do a clear figure. That's why I say take your time to do the figures of the problems, no? Yes. It's up to you. It's really up to you. It doesn't matter, okay? Okay, so we got here the first one. Now we need to find the velocity of B from point C. So now, is that distance fixed? No, so that means we're gonna have the relative term. So velocity of B with respect to C plus omega BC cross S of B with respect to C. All right, so let's, we're thinking, what is VC? 0, no. What are we going to know about VBC? We're not going to know the magnitude, but we're going to know the direction, no? And then I'm going to do a little figure. So let's say we have magnitude of V with respect to C. E, I call this one again, maybe already know. Tangent, no? Or perpendicular. Plus, here I go, I, JK, so 0, 0, -4. I'm not using enough space, so it's going to be crowded. And next, what is the position of B with respect to C? So we know the height. So that distance should be equal to what? Basically the correct 1,000 minus what we had before, no? So what is that? Well, basically it will be 500 minus the R cosine, no? Do you all see that or not? Which is how much? Wait, I can go and check if you want, since we have the solutions here. Let's check if you want. That should give us.
Yeah.
They don't give us the value, so
142.95.
Okay, so they're 142.95. And now you can see the figure that I'm going to do next, okay? Which would be something similar like this one. So 142.95, you put over here 142. .95, and again, now what would be the direction of B here? We need to look at the center of the circle, no? Yeah. So maybe I should end the figure. So we know that. Let me do it in red. So we know that You can guess, but you can say this will be your velocity of B with respect to C, which you know will be, this vector will, over here will be the E tangent, and this one here will be what? The E, no? Yes. Okay, I didn't pay attention. So position of B with respect to C, you are correct. Negative. Thank you. So sorry for that. I know it's very small. I can zoom in for a second if I know how to do that. Yeah. Sorry for that, guys. Just so it's negative 142.95 and 350. Okay. Now, what is the trick, or how do we find the perpendicular vector? How do we do it? The other day. We first find the E, no? And then we flip the values and we put one negative sign in one of them, no? Okay. So let's see if we can do it over here in this figure. So from this figure, what would be the E? We have the angle, so
I mean, just bring it down to
the B, cosine beta, sin beta. So give me the values because it's going to be easier. Switch the values easily on the cosines.
so cosine 0.714.
Okay.
0.690.
0.690.
0.700.
700. Okay. Okay, you do the math. Okay. So now, if we look at the figure here, it's in red. Okay. Our E hat perpendicular. So what do? We flip the sign, so we have 0.700, 0.714. So the way it's plotted, on which one do I need to put the change the sign? On the X, no? The way it's plotted. If I were to plot it down, it will be on the Y, no? Okay? So now I can just go and substitute into this equation here. So let me zoom out now. I'll try to write it a bit bigger. So let me go zoom out more, so that's fine. All right, so here I am. So now this will give us that VB will be equal to magnitude B with respect to C. We know this would be negative 0.700. It will be 0.714 plus, if I do the cross product, I will get so 1200, so positive 1400, no? And then the other one, I'm going to need your help. 4 times 142 times 95. How much? 71.8, and that should be positive because it's negative times negative. Yes. So yes, that's what it is. So basically, this is going to give us the equation that VB is equal to negative 0.7 velocity of B with respect to C plus 1400, 0.714 velocity of B with respect to C plus 571.8. And this will be our equation. You see, always the same procedure, no? What is the next step? Perfect, we equate. 1 and 2. So what do we get? Negative 350 omega AB equal to negative 0.7 velocity of B with respect to C plus 1400, 857
Minus.
upper negative, no? 0.5 omega AB equal to 0.714 velocity of B with respect to C plus 571.8.
Because we got a negative.
Let's see. Yeah, but we switch the sign for the X, no?
But negative times, negative 4 times negative.
Yes.
Yeah.
So now with your magic calculators, you're gonna give me the result here. Solving for omega AB and the magnitude of BC. And then I'm gonna ask you to give me what is this one here. To give me the vector. Zoom recording. So 1.72 for omega AB radians per second, and the magnitude of B with respect to C 2.85. Somebody else agree? 2.85
Oh.
or 2.2 millimeters per second we have so far. So 2.28. Okay, so now I want you to give me this in where the this one was what? So 2.28 times 0.7.
The 2.2.
No, millimeters per second.
Yeah, he gave the answer.
Oh, so it's 2,280?
Yeah.
So this one will be what? So 0.7 times 2,280? How much is that? 1596. Okay, and 0.714? 1627.92. Okay. All right, great. But again, I think you should practice a bit to be a bit faster on these calculations, okay? All right, so now that we did the velocities, what do we need to do? The acceleration. So let's start by the easy one. The first one will be to find the acceleration of point B from point A, no? Let's do acceleration of B from point A. In this case, there is no relative term, okay? You do the same thing as for the velocities. All right, nothing changes. So plus alpha AB cos S of B with respect to A minus omega square AB, S of A with respect to B, B with respect to A. B with respect to A over here, okay? Okay, what is acceleration of A? 0, so we first do the tangential acceleration. I, J, K. Do we know alpha AB? No, that's what we need to find on the problem. Now, position of B with respect to A, we can use the one that we had before, no? So 857.05, 350, and 0. Minus omega AB, we just found that to be equal to 1.72 square times 57.05 and 350. So again, here I'm going to need your help doing the calculation. So this should be equal to what? Negative 350 alpha AB, 857.05 alpha AB, minus a value, minus a value. That should be equation 3. So how much is 172 squared times 857.05? 2,535 point. Point five?
Yeah.
Okay. And the other one? 1,035.44. Okay. I mean, this one is straightforward, no? Now the next one is the one that is going to need some thinking. So a good figure. I mean, I always say, if you get a good figure, it's easy, no? All right. So next, we need to do the acceleration of position, acceleration of B with respect to C. So we got, do we have the relative term? Yes, we have acceleration of C plus the acceleration of B with respect to C plus alpha BC cross S of B with respect to C minus omega squared BC S of B with respect to C plus 2 times omega BC cross V of B with respect to C. All right, so here comes, we're going to take it slow. From this figure, what is the acceleration of point C? 0. Okay, now let's see if I can do a better figure than before. So we have this. This is our point B over here. This will be our point D. Okay, so now what do we know about the acceleration? Correct, we're going to have 2 components. So this will be acceleration of B with respect to C on the E tangent, no? Is the tangent component. So basically this term is going to give us here acceleration of B with respect to C E tangent, no? Okay. And then it's going to give us another term that is going to be pointing in. This one is really perpendicular. This one is more called the normal, no? So if you remember, this one was equal to what? So if one is A normal, if you want, A, B, C, E. Let's do this again. Here the details here, A, B, C, E. But this one we say, you could say that it was equal to what? Go and look at it, okay? Don't make it up.
It's
The normal. So if you remember, I did a small calculation here, like this should be equal, the magnitude should be equal to omega square R, no? Talking about magnitudes, but we know that V is equal to what? Omega R. So if you rewrite omega as V over R, this gives us V squared over R, no? The magnitude. We did that the other day, no? Okay, so really this one here will be equal to magnitude of velocity of B with respect to C, if you want to be accurate, divided by R times E. Is a relative velocity that we calculated before. That is a perpendicular. Oh, the square, yes, I forgot the square. Sorry. Okay, let's stop for 10 seconds. Do you understand that? Does that make sense? Okay, so from now on, really it's just a matter of algebra, no? Okay? All right, so from here we can say then AB will be equal to what? So let me just rewrite this. AB relative to C, E, then, I mean, what do I need to say? Do you want me to write this one here? Do you want me to put the magnitude, the direction over here on E, or? I mean, let's not put any sign now, and then we decide. E plus, I'm just going to write under this form, and then we start putting matrices. Otherwise, I'm going to run out of space. Okay, so the reason why I didn't put a sign here is because I want you to be careful with something here. So I'm going to jump here. All right. So this, we don't know the magnitude here, but we know the direction. What is the direction of the E perpendicular? Calculated that before. It's what? Negative 0.700, 0.714. Correct? Now, this one here, I'm still gonna know the put a sign. I put V squared B with respect to C divided by R. What do we use for E?
0.714.
Okay, 0.714, 0.700. But now this was going in what direction? From point D to point B, no? Yes? But this one is pointing in what direction? So do you want to put the negative sign over here or front? Does that, do you see what happened here or not? Yes? If not, it's time to say no. Okay, we look at the figure again. All right.
That was going down to from B to D.
Correct. And the E, and when we define the E, we define it between to D to B. Okay. Okay. In an exam, that would not be. I mean, yeah, that would be a mistake. Okay. It's important to know the direction. Okay. So next we have here plus. Okay, so JK, I leave a lot of space because I know we have those. So we have 0, 0, and alpha BC is given to us to be equal to 10. All right, so 10. And then the position of B with respect to C, I'm just going to copy from this case over here, which is negative 142.95, 350, and 0. So that's only for the third term, okay? Now I'll go, so this is the tangential acceleration term. Now I'll go to the normal acceleration term. So minus omega BC is given to be -4, so -4 square, okay, from the first page, all right, times B with respect to C, we know what that is the -142.95 and 350 plus, and this is the one that generally we do mistakes, JK 0, 0, and generally I put the 2 over here. What is omega BC? So it's 2 times -4, no? And then B with respect to C, I asked you before to give me that result. Let's see, what is it?
1596. 6.
Yeah, but where do I have it? Did I lose that page already? Yeah, no, I have it here. 15 negative, no, 1596, the first one. Is that correct? Negative 1596. And the second one, 1627.92 and 0. Should be negative because it's going into the direction. So now, you know what, no? So now this is going to give us acceleration of B is equal to -0.700 acceleration of B with respect to C. So everything is going to be known over here. So go ahead, I give you some times. Because VBC over here, what is the magnitude of here of VB with respect to C? Before you told me was equal to 2,280, no? And R is 500. So the only unknown over here will be B with respect to C. So it will be 0.714 acceleration of B with respect to C. And then over here we have some constant values that you're going to give me. I give you some time to find those values. So let me pause. So again, sorry guys, I forgot to put resume recording. So I guess was for this calculation. So the next step is to equate 3 and 4 and to solve for alpha AB. So since it's the same data for everybody, let's see what we get and compare because we probably use slightly different data. 17,137. Okay, don't look at this. Just go and look at your solution, okay? I just want to see if they round off how different it's going to be. It is the same data. 135, 136. 137. What did we use for omega IB? 22.65? $1.72. Oh, no, that's alpha IB. No, good. Okay, so that should be the answer. Is I'm looking for omega AB. What they have over here. They don't have it, no? Oh, maybe down here. Is it the same data? Okay, what's the value we found for omega BC? I don't see here which value to use. Okay, don't pay attention to what they have done here. I don't see what they have for omega BC. All right. Let's see what we get and let me know. I mean, I think on the process is correct. We're gonna find out now. So we find 13.1. Resume recording. Not gonna be good. So in this case over here, what happened? But this one is still 1.72.
Yeah.
Okay, but velocity of B with respect to C is what? 4,000.
So, yours is
If you go 4 yard meters,
4 your meter.
this would be 4,000 millimeters per second. Okay. So that means, guys, that this here is going to be different. And from now on, everything from there down is going to be everything different, no? So it's good. After all, I'm happy because that way you can just not go to the problem or the solution and just plug what we did in class, no? You need to go and rework out all the values. But the process is correct. What I care is about the process, no? Yeah, the calculation is what is hard here. I mean, easy. I wouldn't say easy, okay? That's probably, I think we have done the hardest problem you can do about this chapter.
Is something like this.
Something like this feasible on the exam, yes. But if you have something like that on the exam, for example, I give you the omegas, and I'll just ask you to solve for the alphas or something like that. So I guess if you now substitute the correct values, yeah, you should get the alpha here to be whatever, 22.65 or something like that. But you need to go down through all the calculations again. Yes. So this one here, you say, or second velocity of B?
So the second one.
Is 142 point, yeah. So what they did, okay, is basically it's a matter of the figure. So let's look at this from this figure, okay? So is that distance velocity of B with respect to C? So what we need here is that distance over here. Correct? Yep. What is that distance from here to here? 500, no? So if you want, that distance would be 500 minus R cosine of this angle. But what they did, when the people did it, okay, what they did different is that they did the 1,000, the whole distance, minus this one here, minus this one over here, minus the one from B to C. That's why they did it pretty quick. But I mean, do you see it or you don't see it?
Yeah, that's exactly.
Yeah, it's a matter of a good figure. Okay, you need to do a good figure, like always. But from this figure will be the 5,000. So 500 minus R cos beta, and R is 500. So it's 500, 1 minus cos beta. And that should give you the 142.95, I guess, okay? Okay, so good. You need to redo this problem with the right data now. Okay, do you think we did enough of these problems? We have done the hardest one, okay? Yeah, I mean, then there is, okay, let's discuss it. So we have about 12 minutes. We're not gonna do it, but we can discuss it, okay? The only other one that we haven't done, which I think is a little bit easier, is this one here, 141. All right, do you have this one on the assignment? Let's do it mentally. And then for you to practice next class, maybe I can do it now because you're just gonna copy the solution, but I don't know. I might consider to do a quiz about this. It's not official, I need to think about it, but what would be the way to solve this problem? Let's see. Bar BC rotates with a constant counterclockwise angular velocity of 2 radians per second. So that means BC, omega BC equal to 2. Alpha BC, 0. Okay? Yes? Does that make sense? All right. Now, determine the angular acceleration of the plate. So this is the plate over here. Okay, so here, this problem, yeah, I mean, it's the same as the other ones, I guess. So again, the strategy would be to find the velocity of one point and the acceleration of one point from two different locations. So in this case, we can find the easy one would be to find the velocity of point B from where? From C. Next, we can find the velocity of B from which point? What about, we know the velocity of A? You can find A, but first you need to find B. You can't find it from here, no? Yes, this one is fixed. Yes? But then what happened? Is the distance between B and this point fixed? No, so you will have the relative velocity. Correct? The relative velocity will be pointing in what direction? Or up or down, no? Yeah? How would you find the, I mean, in this case would be easy because this will be just on the y direction, no? The direction. So the E will be what over here? The E perpendicular will be what? What will be the X? 0, 1. Yeah? It's easier for in that respect, no? Okay? All right. So now you equate those two relations and you're going to find the omega of the plate. And the relative velocity of B with respect to whatever this point here is over here, no? Would be the notation. Next thing, you do the same thing for the accelerations. You find the acceleration of B from point C. It's an easy one, no? Then you find the acceleration of point B from point whatever, D, this point over here. Now, the relative term, acceleration of B with respect to this, will have how many components? 2. 1, that will be A, B with respect to D, 0, 1. And then this one, that will be what? Negative relative velocity of B with respect to this point squared divided by R, which is 40, no? Times what? What will be the vector? 1, 0. Does that make sense? So this one actually, there's not that many calculations, no? Because the vectors here, we know what they are directly, no? Does that make sense? Yes, what's the question?
How would you be using point A in this problem?
You don't really, you just use it to know point A in this problem is what point D was for us before on the other problem. Is the point from where you know the center of this circle over here.
RE would be point to A or that point at the base?
So the position of B with respect to A is 40. Then the position of B with respect to this point will be 40 as well, looks like. And this will be, the Y will be 0.3. Yeah, that's pretty strange that this one is 40 as well. Yeah, I know it's normal because it's right over here. You see, this point could be exactly as the other one. If we move this point at a different location, then you need to find what is the X location, no? It becomes more complicated. But since it's right there, you can have it. Okay, so I like this problem. So that means this could be easily an exam problem, no? Since the E's are not complicated, there is no trigonometry involved, no? Yeah? So if I was you, I would prepare this problem. No, it looks like